Hello, in this video, let's walk through the use of several R packages for calculating risk ratios and odds ratios in epidemiologic studies. Okay. First one is the epIR library the package. So I loaded into my RStudio session, and then I want to use the matrix command to create a matrix with some cell counts. It's a 2x2 and with exposed, non-exposed, disease or non-disease. Okay. This is what the data set looks like. So it's a 2x2 table. The next one is I want to use the epi.2x2 function in the epIR package. So every time you use a new function, I strongly encourage you look up at the help file. So here you can see on the right hand side, it tells you this function. How do I get there? Okay, so it's a summary measures for count data presented in a 2x2 table, and you can see the usage, put in certain arguments in there. So here I just use epi.2x2. It's interesting because it's a DAT date equal to it doesn't say data equal to, so but anyway, so pay attention here. I use s.table of data because data originally is a matrix. So here I'm feeding it into this function, but as a 2x2 table. Okay, so I'm gonna use date equal to s.table data, method equal cohort count. So I'm treating this data as if it's from a cohort study. Okay, so then everything is stored in this result object. So you can print it out. Tells you the original data set, and then the incidence risk, give you the estimate, and then the confidence interval, also the odds ratio, attribute risk, attribute fraction exposed, attributable risk in the population, attributable fraction in the population. So these are all risk metrics used in epidemiology. I will not go into the definitions and details about these metrics. In this video, I just want to show you how to calculate them. Okay. And also, it gave you a chi-square test for the OR equal to 0. Gave you a test statistic and a p-value, and the world confidence limits and CI confidence interval, which is not calculated here, but it's I think presented in the table above. Okay. Another way to look at the result is using the summary, and this gives you a lot more information. If you look into the help, the documentation, it has very detailed information about all these statistic this function calculated for you. Okay, so you can look into it and see what is the information you're looking for. Okay, the next R package I want to use is epitools. So get it in here. Okay, and then here I'm going to use the risk ratio world. So it's going to calculate a risk ratio with the world confidence interval. Okay, so this is what it looks like. It's the rate ratio and also the lower and the upper confidence bar limits. Also, it gives you 3 p-values, give you the mid p exact, the Fisher's exact, and the chi-square exact p-values. Okay. You can also calculate the odds ratio dot world. Okay. And it gives you similar situations here. Give you the point estimate and also the confidence limits and also the p-values. Okay. If you want to take a look at the help documentation, this tells you there's different ways you can calculate the odds ratio. You can calculate all of them, or you can calculate, say, mid p or Fisher or Wall or small. You choose which one you want. Okay. All right. The last one is a more comprehensive package called the riskCommunicator. So this one is I loaded in. We can see the random seed. So this is a very comprehensive package. Let me stop the recording of the RStudio session. Okay, now we are at this R documentation page for the package riskCommunicator. So it is actually for the G computation to estimate interpretable epidemiologic effects. And this, I think, is from let me see, G comment. Yeah, this is come from the work of James Robbins. Okay, so it's a very mathematical and complicated estimator of effects. And then here you can see it actually has a subset for the Framingham and the CVD subset. So it has a lot more information. So here, in this video, I'm just gonna make a brief introduction. I'm gonna demonstrate the use of GCOM. So the use of GCOM is here. Let's see here. Yeah, GCOM to estimate difference and odds ratios with 95% confidence interval. And you can see it has Y, X, and Z. And Y is the outcome. X is the exposure, Z is the potential confounder. So this is what I want to show you. Okay, here we're back in the RStudio session. Let me create some artificial data set again. So this is the number of individuals, 200. We're gonna get a exposure variable. Just draw a random sample of 200 from a binomial distribution with equal probability of 0 or 1. And we can have a confounder variable. Here we draw from the normal distribution. Okay, so we're going to get a continuous confounder. But here, for the outcome, we're going to generate from also a binomial distribution, but the probability of success would follow this logistic function of 0.3 times exposure plus 0.05 times the confounder. Okay. And then we put them together into a data frame. Here's the first few rows. You see the exposure, confounder, which is continuous, and outcome. Okay. So to actually use the GCOM function, we simply put the data equal to data and a Y equal to outcome, X equal to exposure, Z equal to confounder, and see it tells us that it's preceded with X as a continuous variable, but if it were a binary variable, we have to do some categorization. Okay, so here's what it look like for the outcome. It's actually gave you the formula. If you read the help documentation, it actually this GCOM function is very flexible. You can actually control for multiple covariates. You can actually fit a generalized linear model with it. Okay, so And then you can see it gave you the risk ratios and odds ratios and confidence intervals, all that. So this is a tool for computing risk ratios or odds ratios in the presence of confounding variables. Okay, I hope this video shows you that R or statistics is useful for epidemiology.